Let's compute probabilities containing the word and. That means we're going to do two things. We're going to do this and that. And I don't know about you, but I love probability. So let's jump right in. Now, pay attention, because when we're doing two things in a row, sometimes we're going to do it with replacement. Meaning I have a jar with 4 things in it, right? 4 different colors. Oh, that's the same color. Whatever. And then I take one out. Whoop! If I replace it, that means it comes back in. That's with replacement. Without replacement means I have 4 things, or however many, right? They're all maybe different colors. And then I do the first one. Whoop! And then I do the second one. You'll notice I had 4 items the first time and 4 the second with replacement. With the second one without replacement, I had 4 items, and then after I took that one out, I only had 3. So it changes our probability. And if you're thinking, I have no idea what you're talking about, I can do an example. Okay, but first, probability with and. That means both things are happening. I'm doing this and that. I'm going to read and journal before I go to bed. Both things are happening. So when we do this, the mathematical way, the probability of A and B, it means we are going to multiply the probability of the first event times the probability of the second event. And the product of that will tell us the probability of the and event. Okay, so what is the probability of flipping a coin and getting a heads, and drawing a 4 of hearts from a standard deck of cards? Okay, so the probability of a heads and a 4 of hearts. Okay, that's my own little notation there. So these are the two things. So when I'm thinking about flipping a coin and getting a heads, right? So we're doing the probability of heads times the probability of getting a 4 of hearts. So when I flip a coin, I have 2 options. So my denominator is 2, because that's how many total possibilities there are. And how many of them are heads? Well, on a coin, just 1. So the probability of flipping a heads is just 1/2. Now, a standard deck of cards, not everybody's familiar with, but a standard deck of playing cards has 52 total cards in it. Okay, so my denominator will be 52. Now, within those 52, they are all unique, all different. There are 4 suits. We have spades, hearts, clubs, and diamonds. And each one of these has numbers ace through king. So ace, 2, 3, 4, up to 10, and then jack, queen, king. So there are 13 cards of each suit. All right, so in this case, we're talking about a 4 of hearts. So the suit is hearts, and the card is a 4. There's only one of those in the entire deck. So the probability of both of these things happening is 1/2 times 1 over 52. So when I multiply straight across, I get 1 over 104. Now, if you change that, a lot of people talk about probability as decimals. We'd get 0.0096. And we're going to do quite a few examples here. A teacher has a bag with 25 red pencils, 40 blue, 35 green. What is the probability of pulling a red pencil and then a blue pencil without replacement? Okay, so probability of pulling a red and then a blue. So we're going to do probability of red times probability of blue. Okay, the first one is the easy one. So how many total pencils do we have? 25 plus 40 plus 35 gives me 100. So we have 100 total pencils. Okay, so the probability of pulling a red one is 25 out of 100. Now, think about this. You've got this bag. You pull out a red pencil. So now we are down to 24 red pencils, right? Because we're assuming this happens. Now we're down to 24 red pencils, and we're down to 99 total because 1 has been taken out, and it was red. So now, what is the probability, the second part, of getting a blue pencil? Well, I still have 40 blue pencils in the bag. That's an awful looking for. 40 blue pencils, and we have 99 total. Now, multiplying this across can get kind of ugly, so we could always reduce, right? I can say, like, I know that 25 over 100 reduces to 1/4. So I have 1/4 times 40 over 99. And then 4 goes into 40 10 times. So I really have 1 over 1 times 10 over 99, which gives me just 10 over 99, which simplifies as a decimal of 0.101. But big difference there without replacement. Let's do one with replacement. You've got the same 100 pencils, so we've got 100 total. And now we're going to find the probability of a red and green. So probability of red times probability of green. Okay, probability of red, we know that one, right? 25 over 100, we just did that one. Now think about this. We took the red pencil out and we're like, woo, red pencil. And then we put it back in the bag. So we still have 100 total because with replacement, that means we replaced it. Okay, so now probability of green, well, there are 35 green pencils, so 35 over 100. Once again, let's reduce. 25 over 100 is 1/4. 35 and 100 are both reducible by 5. So this gives me 7 over 20. And then we multiply straight across. So I would end up with 7 over 80. And that simplifies as a decimal to 0.0875. All right, I have 2 more examples, one including a table. But you have a bag of marbles, 10 red, 8 blue, 14 green, 17 orange, and 4 yellow. What is the probability of pulling 4 consecutive yellow marbles without replacement? Oh, this is a good one. This is like a challenge problem. So we're talking about yellow and yellow and yellow and yellow. But we're not replacing, right? Without replacement. So how many total do we have? First, let's add 10 plus 8 plus 14 plus 17 plus 4. And we see that we have 53 total marbles. Okay, great. So let's start with the first one. Probability of pulling a yellow is 4 out of 53. Okay, so I've taken a yellow. I'm down to 3 yellows and 52 total. Okay, so we do it again. Probability of a yellow. Now I have 3 over 52. Okay, so I took one out. Now I'm down to 2 yellows and 51 total. We do it again. So I'm now at 2 over 51. I'm down to just 1 yellow marble and 50 total marbles. And then we do it again. I'm down to 1 marble out of 50. Okay, so these are the 4. Now, I'm going to do this reducing pretty quickly, but it's kind of awesome how it works. So 4 goes into 52 13 times. 3 goes into 51 17 times. And 2 goes into 50 25 times. So I have 1 over 53 times 1 over 13 times 1 over 17 times 1 over 25. Feel free to pause and check that out. But we end up with a probability of 1 over 292,825. As a decimal, you've got 5 zeros and then 3415, meaning it is highly, highly unlikely that with this bag of marbles, we would actually pull 4 consecutive yellows, but still fun. All right, I want to do one more. This is kind of a long video, I apologize, from a table because we're going to play with more tables as we go. So we have a table about are students wearing glasses, yes or no, and what color of shirt are they wearing, red, blue, or green? So the first one says, find the probability that someone says, yes, I'm wearing glasses, and they're wearing a green shirt. So we're looking at yes and green. Where do they intersect? That's the numerator, and this is over the total. So this would give us a 7 out of 36, which is 0.1944. So you can see when we have a table, we don't have to multiply. We just have to use it to find what we're looking for. Similarly, in letter B, find probability of no and red. So here's no, here's red. Where do they intersect? And that's right here with 8. So that would be 8 out of 36, which as a decimal is 0.222. And that is probability with and a super good time.